Okay, class. So we are now on the example number 6. Kindly open your modules on page 5. Okay, so in example number 6, we are given here the 12.5 cubic foot. Okay, this is already our volume. We also have the 120 degree Fahrenheit. Obviously, this is our temperature. And we are given the 40 psi, or this is your pound per square inch, which is absolute value. Obviously, this is our pressure. Now, the air is compressed to 2.50 cubic foot. Okay, take note of the term compressed, which means that this is already the final volume of your air. Okay, and from this data, we could say that this value 2.50 is already the final volume. So which means that initially the air is at 12.5 cubic foot. So let's name this as V sub 1 for the initial volume and V sub 2 for the final volume. Now, for the required for this problem, we have two requirements. We have for letter A, we have for the first condition, this should be isothermal. Okay, isothermal, and we have to solve for the final pressure and your bulk modulus of elasticity. Okay, while for the second condition, it should be adiabatic, and we are to solve for the final pressure, final temperature, and the value of your bulk modulus of elasticity. Okay, so class, kindly open your modules on page 4 to check the formula for this condition. So on page 4, under the isothermal conditions, so we have here the ideal gas law that will become P sub 1 V sub 1 equals P sub 2 V sub 2 if our temperature is constant. Because class, during the isothermal, your temperature is constant. Okay, constant siya, and therefore our ideal gas will become like this. So to solve for the P sub 2, so we will simply divide both of the equations by V sub 2, and this will be our working formula. So from here, okay, so from here, substituting, we'll have P sub 1 is, by the way, this is our P sub 1. We have here 40 psi times your V sub 1, which is 12.5 cubic foot, divided by V sub 2, which is 2.5 cubic foot. Okay? So class, you don't have to convert in this case. It's because our unit cubic foot here will be cancelled out and we will be left by the unit psi. So you don't have to convert. Okay, so P sub 2 will be, using your calculator, so that is 40 times 12.5 all over your 2.50. Okay, can you see it? So there, the value will be 200. So what will be the unit? It will be in PSI. So that is already one of the answers in your letter A. Now, aside from the P sub 2, we are asked for the bulk modulus of elasticity. Now, in an isothermal condition, what is the value of our bulk modulus of elasticity? Now, looking at your lecture, your bulk modulus of elasticity is just equal with your pressure. Okay? So, therefore, class, the value of your bulk modulus of elasticity will be, it will be equal to this 200 psi also. Okay, so that is our answer for letter A. Okay, so how about for letter B? So take note, class, in letter B, our condition is it should be adiabatic. Now, looking at your lecture, adiabatic has the formula P sub 1 V sub 1 raised to K equals P sub 2 V sub 2 raised to K. Okay? Now, what is this K? Remember that K is the ratio of your specific, what do you call it again? Ratio of your specific heat at constant pressure to the specific heat at constant volume. Okay? Now, where should we get this value of K? Now, recall that in the problem, the given substance or the given fluid is air. Okay? Air. So, there are already class values regarding this. And as you can see here in the table, can you see it? So, there are values there, which is, as you can see, K for air is 1.40. Okay, so this will be our value to be used there. And as you can see also, you can observe there is also a value for gas constants in certain substances, just like in your example last time in the methane. As you can see, the constant R has a value 96.2. Okay, the same as what we have used in our problem last time. Okay, so using this value, so to solve for P sub 2, we have P sub 1 V sub 1 raised to K over V sub 2 raised to K. Okay, so substituting, our P sub 1 is 40 PSI. Your V sub 1 is 12.5 cubic foot. It should be raised to 1.40 all over your 2.50 cubic foot. And this should be also raised to 1.40. Okay, class? Now, take note that we don't have to convert in this case. Why? Because this will be cancelled out. Okay, all you have to do is raise this 12.5 to 1.40 and the same with your 2.50. Okay, so we have 40 times your 12.5 raised to 1.40 and then divided by 2.50 raised to 1.40 there. Okay, so from that you'll have the value 380.731. And what will be the unit? It will be PSI. Okay? So this is class one of your answer for this letter B. Now, aside for P sub 2, we also have the T sub 2. Okay? And to solve that, we have the formula T sub 2 over T sub 1 equals P sub 2 over P sub 1 K minus 1 over K. Can you follow? So, our target is T sub 2. We have already T sub 1, which is 120 degree Fahrenheit. But take note, class, that degree Fahrenheit is not our standard unit for temperature. It should be in Rankine. Okay? And for us to convert your degree Fahrenheit to Rankine, what should we do? We should add 460. Okay? So that our temperature would be in Rankine now. So, therefore, 120 plus 460, it should be 4 plus 60 there, you'll have 580. 580 and the unit now is degree Rankine. Okay? So, our working equation will become, so this will be multiplied there. So, T sub 1, P sub 2, P sub 1 raised to K minus 1 over K. Okay? So, let us substitute. Your T sub 1 here is 580 degree Rankine. Your P sub 2 is here. We have already solved it earlier. 380.731 PSI all over your P sub 1, which is 40 PSI. Now, we have to raise this to this quantity K minus 1. So, K is 1.40 minus 1 all over your K, which is 1.40. Okay? So, let us simplify first the equation so that we can solve it properly. Can I erase this part? So, I will erase this. So, you can screenshot or you can play it back later because we don't have space for in our whiteboard. Okay. So, here, so I'll rewrite this. So, we have T sub 2. So, 580 degree Rankine. What can you observe, class? This can be cancelled out. Here, this one. Can you see it? So, cancelled out. So, let us simplify this. 380.731 over 40. There. So we have 9.518275. And it will be raised to this quantity. Let us also simplify that. 1.4 minus 1 over 1.4. It will be 2 over 7. Okay, so instead of this complicated fraction, I'll just use 2 over 7. Can you follow? 2 over 7. There. So using your calculator, so T sub 2 will become, so 580 times 9.518275 raised to 2 over 7. So we have 1104119, and the unit is degree Rankine. Can you follow, class? So that is another solution for our letter B. Now, for the last unknown, which is the bulk modulus of elasticity, so take note that under the adiabatic condition, your bulk modulus of elasticity is equal to K times P. Can you follow? K times P. Now, what is our K earlier? That is 1.40. And our pressure was 380. That is our P sub 2, 380.731 PSI. Can you follow? So, using your calculator, class, the value will be 1.40. This one. 1.40 times 380.731. There. So we have 533.0223. And the unit, of course, is still in PSI. Okay? And that's it, class. That's the solution for our example number 6.